Hello and welcome to this course on Applied Ergonomics lecture 22. This is actually going to be one of the last lectures because after that uh, uh, one of my students who is also the TA for this course will also give you some illustration about different problem solving aspects in ergonomics for about 1.5 hours or so. So, we were talking about the various joint motions, and in relation to that we discussed the various motions which were followed of a human joint, particularly a knee joint or an elbow joint. And as you can see here in this schematic, the motion of one joint in terms of a swing with respect to the other joint is typically about an axis, the mechanical axis, and the path is followed by a rotation about this axis. So, if I wanted to look at a joint, it would simply be comprised of a concavity and a convexity, as can be seen here, and then there are two different principal motions which can be there associated with the how the convexity moves with respect to the concavity. One is a rolling motion where the convexity moves over the concavity by shift of an angle. So, if I could consider the different axes of this, so there is a change of position in respect of this convexity, okay, over the concavity here, okay, in terms of a rolling motion, or a sliding motion where there is a physical displacement in a certain direction of the again the convexity over the concavity, okay. So, these are the two different motions which are involved in describing the overall joint motion about which such swing etc. can take place. So, when we talk about sliding and rolling motions, there are of course different directions associated with these motions, and therefore, there have to be some preset rules which need to be applied for looking at the rolling and sliding motion, so that it can give an idea of in which direction it is rolling as opposed to sliding. So, let us say when we talk about such concavity, convexity relative movements, there are certain rules which relate the expected coupling of the rotational and the translational movements associated with such joints. So, if we are talking about a finger joint, for example, so obviously as one can see here, there is a again a convexity which is again going over a concavity or a concave portion, and as we are bending the finger downwards, basically it shows that both the rolling and the sliding motions are in the same direction. Whereas, if we looked at something like a movement of convexity over the concavity, or let us say if we talk about a shoulder joint here, for example, when the arm is moving upwards, let us say the arm has been moving in the upward direction. So, as you see here, that sliding motion can be in the upward direction, or the rolling is actually in the reverse direction of that. So, when a convex surface moves on a concave surface, the roll and slide would occur in opposite directions. So, such movements or such rules are followed when we talk about one such concavity moving over the convexity or vice versa, and this rule is obeyed more or less in all the joints of the human system. So, there are also certain constraints that we have to impose, otherwise there will be dislocations. For example, if we wanted to just purely roll let us say one joint over, or one portion of the joint over the other, it may result in joint dislocation. For example, let us see if you are just rolling about this axis, let us say about the vertical axis, let us say, and then there is a rolling motion of this particular joint which has this convexity here about the axis without any sliding motion, then obviously there is a separation which happens for the roll to continue in a pure roll manner if there is no translational motion as such. So, the ideal situation would be that while rolling it also slides over one another, so that such distances, as you can see here, otherwise because of pure roll does not get introduced. Okay. So, pure sliding motion can also sometimes results in joint impingement. For example, let us say if there is no rolling action and only the sliding action of a concavity over the convexity, there is always a possibility that there is a engagement of the concave part, as you can see from the dotted portion, with this convex part of the joint. So, we have so far given a sort of a more like an introductory overview about biomechanics. Actually, the field of biomechanics is a lot broader than what we have taught here, but because it's an introductory topic in a course of ergonomics, therefore I feel that whatever has been described so far has given you sort of a purview of what is the kinematics or the dynamics associated with motions of the various subsystems of the human body, which would result in sometimes giving therapeutic assistance as well as engineers and occupational therapists ideas and concepts about work design. I would now move into a slightly different direction, detour from applications from actually study of the fundamental biomechanics to the application of biomechanics. We would like to investigate certain guidelines or design principles which are available for designing seating postures. As you all are aware that in the current context of the work systems, a large section of the work systems really works with huge amount of data analytics or even software development, where there is a continuous need to sit and work, and so therefore there are certain guidelines which have been generated from time to time across the world by different sort of standard organizations or international standardization organizations related to even seating posture, because what has been found out that because of this large section of the human factors associated with work system which are related to so called handling large data across different computer systems or workstations, there is a need, there is an increased amount of health risk which is posed, and therefore standard guidance needs to be given to designing of how even a person sits across in order to perform work in such work systems. So the following would be a sort of overall purview of the discussion. So we will have an overview of the standards, particularly which are the organizations which would provide such guidelines or standards for proper ergonomic design of computer workstations. We would also focus on some of the inconsistencies associated health risks which are available because of focus studies on some work groups which met such inconsistency of postures. We would also look at some suggestions for the modifications which can be permissible in the overall ergonomic standards which are made from time to time associated with such seating posture designs, particularly for workstations. So if we looked at all the different standardization organizations, they almost all have now standards associated with designing of computer workstations, and so some of the very lead players in this are International Organization for Standardization. There is a guideline which is associated which is actually the largest organization of standardization in Europe or European countries. So there is a ISO 9241 guideline which is actually used for such ergonomic designs. There is also national standards and some Australian standards, AS 3590.2, which are dedicated to how workstations should be designed, how different seating postures associated with such workstations should be mandated across people who handle such equipments or work across the globe. There are also Canadian standards, the particular standard number is given here, or American standards which are again done by the American National Standard Institution. There is HFES 100 which are prevalent across the United States in terms of implementation for computer workstation design. So let us look at some of the postures and associated health risks and also some recommendations, okay, which are made by almost all these standards, whether they are in any different part of the world. So about the seating posture, there can be a major health issue of back pain associated with how a person sits for a longish time in such a workstation, and some recommendations which have been made is that they should be typically sitting up straight, or there should be some so there should be some guidelines for how much would be the working height or how much would be the span of the height up to which this chair etc. could be adjusted. There could be something related to reclining, how much leaning backward is allowed. There is also some tilt forward which is also allowed, and the standards which would be associated with the seating posture should typically address almost all these issues. So when we talk about the placement of the monitor, particularly the computer workstation monitor, there are certain health issues related to that. The major two are neck pain and eye strain, and there are certain again guidelines given in terms of or recommendations given in terms of what should be the viewing angle, what should be the viewing distance, and typically the recommendations that are generated across all these different standards are that the viewing angle has been worked out to be most comfortable if it is between 0 and 60 degrees, and that is with respect to the horizontal. Then even the viewing distance should be as good as the screen size. So for typically computer based workstations it's 63.5 centimeters, for tablets it could be as low as about 50 centimeters, on notepads it could be even lower, for 43.5 centimeters. And so you know what viewing distance means here. So if for a computer working professional who is sitting in a workstation, you have associated standards with the monitoring or the monitor height and the viewing angle associated with it, a backrest angle, a lumbar support. There is also a chair height associated with such a person, and I will come to some of these recommendations later. There is also something related to how an armrest should be designed or how the feet should be placed typically, so that there is no health issue related to continuous use of this posture by a certain operator, okay, sitting in such a station. So when we talk about the health issues related to the designing of this seat pan, right here, again there are severe issues indicated. For example, there can be musculoskeletal disorders, particularly on back or legs or even buttock regions or arms of a person who is continuously using, if it is not properly designed. And in respect of some of these health issues, some guidelines have been set up, some recommendations have been given with respect to what would be typically the seat height. So the seat height range particularly starts from the knee height of a person. So the standard knee height is taken to be the height of a upright standing person from the ground. And so if I looked at the range of the seat pan height, it is starting from the knee level all the way to some distance, and so that allowed distance is about close to for the seat pan, the height range is close to about 38 to 56 centimeters. Okay, so this is in view of normal sort of the structure associated with the human factors of a work system. The seat height should not be too low, it should also not be too high, it should be just about the right, so that you have a proper posture and no stressing of the musculoskeletal system while continually using for long time or long duration such postures. There are also some health issues and some recommendations related to the backrest design. For example, if the backrest is not properly designed, there may be many health issues because of inability to support the back in various seating postures. Health issues could be related to again muscular disorders or body pain or pain of the neck particularly. And so the recommendations are that typically the backrest height should be in the range of 43 to 53 centimeters. This right here is the backrest height, or there should be a tilt angle associated with the backrest, which is again varying from 90 degrees all the way to 120 degrees. So this is again recommended for a good seating posture. There is also a similar kind of health issues and guidelines associated with the armrest design. So if the armrests are not properly designed, it will generate additional loads, muscular loads on neck, shoulder and arms, particularly forearms and elbows, and also put a load to the spine, which is definitely a very serious matter. Okay, so therefore there has to be some recommendations in that sense for the armrest. And so typically the recommendations made by all these standard organizations are attachable, detachable armrests. A lot of study has gone into all this in order to make these recommendations come up by the different standard organizations. The typical length that the armrest should be about 25.5 centimeters, looking at generally the human systems or human factors associated with such work systems. The height from the pan should be about 18 to 23 centimeters of the armrest, which is typically a comfortable posture for the arm to be just at the proper level associated with the user. of such area. So there should be something related to where you are placing the arm with respect to where you are seating. Okay. So there is also a distance between the armrest which spans about 44 centimeters or so, looking at all the different requirements generated by different individuals, heavier or lighter. Okay. There are also thickness related to issues. Thickness are typically the breadth of the armrest across which you are resting the whole elbow, and so they should span about 6 to 9 centimeters. And basically you can look at this cartoon here to see how it may make seating very uncomfortable if the armrest is too high or too wide and high in comparison to just about enough, so that there is proper relaxation while seating, okay, in this kind of a orientation. So having said that, I have now reiterated certain standard organizations which provide recommendations and the recommendations themselves. So let's now just change gears a little bit and look into what would be an approach that would be needed for in a very participative manner in an organization implementing some of these issues related to postures or mechanics associated to the human factors. Obviously one thing that we realize is that whenever we implement something in this direction which is completely new, it has to be more like a participatory approach where you ask the stakeholders, the human stakeholders associated with such a work system, what exactly is their problem and what is their need. So once that is recorded somewhere, which could be in form of questionnaires or which could be in form of let us say certain associated principles, you can ascertain about what are the requirements in order to make life easier for human factors associated with such work systems. This is a small schematic which represents a sort of an ideal situation of how a person would be sitting in a relaxed manner, shoulders relaxed, for example, forearms and hands in a straight line, lower back supported or forearms level tilted up slightly or thighs horizontal. There should be sufficient clearance under the work surface, there should be flat feet on the floor, there should be a screen position to avoid reflected glare, and top of the screen or slight the vision angle or the viewing distance could typically go all the way up to the top of the screen, but it could be slightly even below the eye level as well. You may need to adjust the height of your monitor by placing something under it or raising if you really want to make a comfortable system for handling computer workstations. So in this particular module we really talk about a participatory ergonomics approach to reduce mental and physical workload, and it's a step-by-step approach to better work aimed at reducing mental and physical workload in office work situation. There is some kind of an introduction which is about introducing ergonomic improvements in a company, which can actually be very difficult. So therefore some participative study has to be done, which also is known as the preparatory step of implementing certain processes related to such ergonomic improvements. It is also important to find the most appropriate improvements once all the improvements have been suggested by all stakeholders who are human factors in that particular company or work system. So you address only some of them, not all of them, because some of them are not very prominent and they may not really help in reduction of effort much. So the aim should really be to do a proper job to reduce few problems rather than tackling all the problems at one time. Also we need to find the most appropriate improvements and increase the chance of successful implementation. There is an approach which has been developed, okay, in this particular study where it talks about two different sections of people. One is a maintenance workers section, another is a agricultural workers section, and then it studies about what are the problems associated with various tasks with these two different work systems, and some improvements made, and then sort of gives a follow-up strategy of what is the level of improvement in associated health risks because of these improvements which are made. So the study that is aimed is about applying and evaluating this ideal approach on several such studies across different organizations. So typically the approach that is being used in this kind of problems is a preparatory step which talks about finding out the the most important needs associated with comfortable work related to a human factor, and then the analysis of if the work is done in a proper manner or not, can it be changed, is there a health impact of that work because of the posture or the associated elements or tasks of that work, and then can we do something so that they can improve the work in a substantial manner so that there are no potential health risks. And then those solutions which come out because we wanted to avoid the health risks in order to do the work redesign need to be implemented, and then after implemented some evaluation needs to be carried out to see whether there is an efficacy of what has been implemented. So typically the preparation step would be in terms of maybe formulation of a committee which could actually look at this aspect, and it can be a more like a concurrent engineering driven committee where there are participants from all different aspects related to the main work system of an organization. So there has to be some commitment with the organizational facilities that this committee should have in a way, and the goals and general framework of the project must be formulated after the steering committee is made. Then there should be analysis carried out in terms of generating checklists or questionnaires at various levels, or even like physical observation methods of the associated tasks with the work system. Several instruments need to be administered in order to identify risk factors and risk groups, and based on this it will give or result in a complete analysis of work and related health hazards which are available in the various tasks which are intended to perform on a regular basis to maintain the work system in a dynamic order. So there can also be choice of certain solutions which are probably the largest risk factors which could be focused and removed, okay, among the different risk groups, and some improvements can be developed and tested on that, can be implemented, and then evaluation step must necessarily provide the information about the efficacy of such measures and indication of additional measures if needed in order to have the right set of solutions for such questionnaire driven problem associated with different people of the organization. So let's look at some of the data that is associated related to how the steering committee prepared some questionnaires. So in one of the aspects, a questionnaire was prepared as to what are the kind of major work that you feel are associated with these works. Particularly the work that was in question was for the maintenance workers and the agricultural workers, and generally, you know, the division of tasks as per the assessment of the people who are directly involved was that tasks could be related to being instructed or coordinating an event or copying or assorting, even reading, filing, data control, data entry, other video work. So these are some of the sort of percentages of responses about what are the kind of tasks where improvement is needed or from where maximum amount of this posture related problems get generated. And the study population was made, the control population here, out of which there was one side which was of the maintenance workers and another of the agricultural workers, and what they report is that out of all these different kind of tasks which have been suggested resulting in problems related to health risks, there are problems related to shoulders which is being suggested by the maintenance as well as agricultural workers. There are problems related to the elbows, wrist, hands, necks, upper back or lower back, and problems could be in terms of pain, it could also be in terms of dislocation damage, so on and so forth. And then, you know, based on this kind of a study, an improvement is sought out of the workplace, and it was sort of deciphered that, you know, out of all these different aspects, maybe the neck complaints, apart from the complaints about the lower back, were actually reasonably important and needed to be solved among these focus groups. And also the workers reported that they wanted a better planning of activities so that they could reduce the peak work overload, particularly mental work overload, just before the deadline. So the idea was that if in a planned manner the work could be implemented, then such problems won't actually strike or it won't happen. So about the mental overload, what was figured out was that there was not enough information to plan the activities thoroughly during a month, and not much could be done about this. So regarding implementation, so after the accessories have been delivered, the ergonomists together with the trained employees in the organization sort of adjusted and tweaked every workplace based on such tasks which were identified earlier, and the associated postures or associated physical efforts, and a brochure was generated to say how to adjust my workplace, which was handed out to almost all the people who are stakeholders in that company or human factors in that company. And there was an evaluation made on how much the complaint has reduced related to the different posture related problems. Particularly there was a reduction, as you can see, in the neck region and almost all the regions, upper back region, lower back or shoulder, from what data was given before the ergonomic design was carried out to after the design was completed. So the working conditions were definitely observed. Questionnaire was used to evaluate whether improvements were actually implemented, and the results show that there was an improvement in terms of percentage of workers reporting complaint. So definitely this whole process of assessment of what you have done and how it really works out is important for suggesting an overall ergonomic improvement of the task structure. So there was discussion carried out. So in this, the stepwise approach with strong enterprise and participation resulted in various changes. Okay, so some kind of a participatory involvement of people who are directly working is very important. So a drawback of the approach was that it is very time consuming. It took about a year's time to implement all the improvements and try to evaluate what was the result of such improvements. And so this is something that cannot really be eliminated. The best idea is to keep on doing it on a continuous basis as and when needed, so that there are no point of times where the complaint has so outnumbered that we have to start afresh. Okay, so it has to be in a continuous basis. The conclusion for this is that the ideal approach is effective in implementing improvements aimed at reduction of physical and mental overload, and it is important to have workers identify the problems and develop ideas for improvements in collaboration with managers for the problems or the solutions to be effective in nature. So I think I will just close this discussion here, where I have given you a perspective of some of the internationally laid out standards or guidelines available for proper posture design, particularly in computer workstation. I have also talked about some basic principles of biomechanics, and then finally I have talked about a particular case and some real data associated with two different kind of workers of a company who report different problems associated with the disorders of the different body parts because of different activities carried out during the task, and sort of discussed also a strategy which could be used for eliminating some problems in a very organized manner in different phases. So I would like to close the discussion here on this area of applied ergonomics, and the following 3 lectures would be done by Mr. Sanjay Kumar, who is also a TA in this course, who will talk about different problems or numerical problems associated with a better ergonomic design for workplace. So thank you very much for being with us. Thank you.